Okay, what we're doing today is going over how to simplify, multiply, and divide the rational functions that we've been looking at for the past few days. So to start us off, we are going to learn how to simplify the rational function x squared. Wow, that's huge. Plus 4x. Let me go back in. Erase that. Okay. There we go. X squared plus 4x plus 3 over x squared plus x minus 6. What we want to do is think about the numerator and the denominator separately. So x squared plus 4x plus 3 and x squared plus x minus 6. And now we are going to factor each of these. So my first one, let's think. This would be x factor. What multiplies to 3 and adds to 4? That would be x plus 3, x plus 1. Looking at the denominator, what multiplies to negative 6 and adds to positive 1? So if I'm multiplying to a negative, that means my signs are going to be the opposite. So one's a plus, one's a minus, and my answer is going to be x plus 3 and x minus 2. Now, using what we've been studying before, I can't have 0 in the denominator. So I need to be setting each of the factors in my denominator equal to 0, and these things are excluded. Negative 3 and positive 2. Now, depending on what happens next, they might be wholes or they might be vertical asymptotes on my graph. So then, once I've decided if I have excluded values, I can pull out or cancel our ratios of 1. So if you notice, both of these have an x plus 3. So those are going to reduce to 1 unless I have the value of negative 3. And I'm left with x plus 1 and x minus 2 as my simplified expression. So my answer would be x plus 1 over x minus 2, except for x cannot equal negative 3 and 2. All right, let's look at the next problem, which has already been typed for me. Sorry. Okay. So x squared minus 25 over x squared plus 10x plus 25. So write that real quick. And now I need to factor the top. I have two terms, perfect squares, so it's a difference of squares. X plus 5, x minus 5. The denominator, what multiplies to 25 and adds to 10? Well, that's going to be x plus 5 times x plus 5. So what are my excluded values in this problem? It's going to be when x plus 5 is equal to 0. So that's going to happen at negative 5. So let's go on and keep simplifying this. I have x plus 5 in both my numerator and denominator. So those are going to reduce to 1. And I'm left with an x minus 5 in the top. Bear with me as I'm learning my new tools here. X minus 5 over x plus 5. So my final answer would be x minus 5 over x plus 5, but x cannot equal negative 5. Okay? And what really happened at negative 5, we had a hole. I also have a vertical asymptote at negative 5. Okay, let's look at this one. This one's a little bit simpler. 2x squared plus 6x plus 3. Look at your top. It has a GCF. My GCF would be 2, and that would leave me with x squared plus 3 all over x plus 3. Now, don't make any magic happen here. Do I have anything that's the same in the numerator and denominator? No. So all I need to do at this point is tell that x cannot equal or has an excluded value of negative 3. It has an excluded value of negative 3. This is my final answer. There's nothing left to do. I cannot factor what's in the numerator, and it definitely doesn't become x plus 3, x minus 3. The end, amen. Okay, our last one for simplifying. M squared plus 5n plus 6 over m squared minus 4m minus 12. Both of these look like x factors, so what multiplies to 6 and adds to 5 would be 2 and 3. What multiplies to negative 12 and adds to negative 4 would be negative 6 and positive 2. So my excluded values are what is happening in the denominator when it equals 0, and that would be at 6, positive 6, and negative 2. So, do I have anything that is going to reduce to 1? Yes, I have m plus 2 over m plus 2, and I have m plus 3 left in the numerator, and m minus 6 in the denominator. So my final answer is m plus 3 over m minus 6, but m cannot equal negative 6 or positive 2. Next, what we're going to do is talk about multiplying, but first we have to remember what happens when we multiply fractions. 1/4 times 2/3. You multiply across the top and across the bottom. So this would end up being 2 over 12, which would reduce to 1 over 6. So here's the formal diagram of what that means. If I have A and C, I multiply and get A times C over B times D. So we need to remember, when you multiply across, not cross multiply. So let's see what that is going to look like when we have polynomials. We get something crazy and beautiful like this. The first thing it's telling me to do is factor. Before I multiply stuff together, factor it, and it'll make your life happier, I promise. So look at your numerator of your first fraction. I am automatically saying I have a GCF of 5, and that there is an x in both of my terms. So I can take out a 5x. And then what multiplies to 20x would be 4 minus what multiplies to 5x squared would be a 1x. And that's going to be over a GCF of x times x minus 1. So both of these had a greatest common factor. And then that's being multiplied to two things. X squared plus 3x minus 4 is x factor. So that would be x plus 4 times x minus 1 over, this is going to be difference of squares, so x plus 4 times x minus 4. And before I reduce, I need to be looking to see if I have any excluded values. So do I have anything in the denominator? Well, I have a lot in the denominator. So off the top, I know x cannot equal 0, positive 1, negative 4, positive 4. That's just coming from setting my denominators at this point equal to 0. And now what I'm going to do is reduce any 1's I have. Well, I see I have an x over an x, so that will reduce to 1. I have an x plus 4 and an x plus 4, so that would reduce to 1. Now, I want you to look really carefully at this right here. 4 minus x, x minus 4. Do you see how those are really similar, but it's like the order is flipped? Well, when I have that with subtraction, it equals negative 1. Like, think if you had 5 minus 3. That would equal positive 2. If I just flip the order of the numbers, that would give me negative 2. So I can flip the order if I multiply by negative 1. So I can reduce these not to positive 1, but to a negative 1. So let's simplify what I have written here. I have negative 1 times 5, that would be negative 5. My x reduced, my 4 minus x reduced, my x plus 4 reduced. So I have x minus 1 over, an x minus 1. And that's it. But look, at this point I realize I forgot a factor. I did that on purpose, y'all. So this whole thing would reduce to negative 5, which means if I graphed it, I would have a horizontal line at negative 5, but I'd have a whole bunch of holes going on. So you want to double check, but if you forget to cancel one, look, I could have gone back up there and done it, and my answer would have been negative 5. So even if you don't reduce all of it at the first time, you can still get the correct answer, which is lovely. Okay, next multiplying one. And this one is actually going to be easier because we don't have all those GCFs hanging about. So first I'm going to factor. My numerator of my first one is x plus 3 times x plus 4 over. My denominator is going to be x plus 4 times x plus 4, what multiplies to 16 and adds to 8. Then I need what multiplies to 4 and adds to 5. X plus 4, x plus 1. And then my denominator there is a difference of squares. So what multiplies to 1 will be x plus 1, x minus 1. And now I need to say if I have any restrictions, anything my x's can't be, and I'm just going to go left to right again. X cannot equal negative 4, positive 4, negative 1, positive 1. So if I thought ahead, I could have done plus or minus if I wanted to. Now I can go through and reduce those things that are 1. So in my first fraction, I have an x plus 4 in the top and the bottom, the numerator and denominator. Looking across, I have an x plus 4 and an x plus 4. And then I have an x plus 1 and an x plus 1. So the only thing I'm left with in this function is the x plus 3 and the x minus 1 in the denominator. But I have all these special things that x cannot equal. X cannot equal negative 4, positive 4, negative 1, and positive 1. And connecting with what we've done before, I had a hole at negative 4. I have a hole at negative 1, and then my denominator that I'm left with gives me a vertical asymptote at x equals 1, and I have an x-intercept where my numerator equals 0, so at negative 3. That's just tying in what we've been doing. Okay, let's look at another multiplying. I believe it's our last one. Here here we go. That beautiful thing. I'm not going to bother reading all that to you. So what multiplies to negative 12 and adds to negative 4 would be negative 6, positive 2. What multiplies to 12 and adds to 8 would be a positive 6 and a positive 2. I'm already happy because I'm seeing that those are going to reduce to 2. Times what multiplies to 36 and adds to 12. That's going to be x plus 6 times x plus 6. And I have a difference of squares. So x plus 6 times x minus 6. Stop now and write down what your limits are in the denominator. So x cannot be negative 6, negative 2, another negative 6, and positive 6. And we'll see whether it's a whole or a vertical asymptote when we look at what reduces to 1. So, do I have any x minus 6's in the denominator? Yes. So, my first factor up there will reduce to 1. I have an x plus 2 over an x plus 2. I have an x plus 6 over an x plus 6. Oh my goodness. X plus 6 over x plus 6. I'm just left with 0, right? No. What have all of these reduced to? All of these have reduced to 1. So my answer is 1. Well, that was boring. Except for when x is negative 6, negative 2, and positive 6. And that means I'm going to have 3 wholes because I don't have anything left in my denominator. So I have only a horizontal line y equals 1 with a whole bunch of holes. Well, that was interesting. Okay, so sometimes we're going to get a lot of stuff that reduces. That's okay. All right, the last thing we're talking about today is dividing. What you need to remember about dividing is that dividing is the same as multiplying by the reciprocal. And what does the reciprocal mean? It just means that we are flipping it, okay? I misspelled that as always. Reciprocal. All right, so let's see what that looks like in real life. Here we go. Be careful. You see we have division right here. Woo! Division. So automatically I'm thinking, hey, I need to flip my second fraction. So I'm just going to copy everything else down. X squared minus 5x plus 6. Yada, yada, yada. But now I'm going to write it as multiplication and flip my fraction. Here we go. So now it's x squared minus 9 over x squared plus x minus 6. Now I go back to my steps of factoring and multiplying and simplifying. What multiplies to positive 6 and adds to negative 5 would be a negative 3 and a negative 2. Always be careful when we're asking what multiplies to 6 and 30. Those are the 2 tricky ones. What multiplies to 9 and adds to 6? 3 and 3. I have a difference of squares on my right-hand side. So x plus 3, x minus 3. And then I say what multiplies to negative 6 and adds to positive 1. So if it's multiplying to a negative, that means I have opposite signs. I know I have an x. Okay. So that's going to be a positive 3 and a negative 2. In case you can't tell, some of these numbers keep coming up because they're like our favorite numbers ever. All right. So let's start reducing. After, of course, I say that x cannot equal negative 3 again, negative 3 again, and positive 2. That's a lot of negative 3's. Okay, let's reduce. I have a positive 3 in my numerator and denominator. I have an x minus 2 in my numerator and my denominator. And then I'm left with this interesting assortment. X minus 3 times x minus 3 over x plus 3 times x plus 3. Now, it would be really nice if these were simplifying to 1 like in that last problem, but I can't magically just make those disappear. So this hot mess is my answer. If you want it to look prettier, you could say x minus 3 squared over x plus 3 squared, but that's about as nice as it's going to get. So dividing, all we have to remember to do is flip our second fraction. So we need to be paying attention to our operation. So this next one, first thing I notice when I see the problem, it's division. So I need to reverse my second fraction. I'm just rewriting the problem. I'm not going to read out all these numbers to you. Make it multiplication. Once you flip, it's multiplication. It should not be division anymore. Otherwise, you get stuck in the sneaky hate spiral of division. It never goes away. Now it's time to factor. What multiplies to negative 4 and adds to negative 3? X minus 4, x plus 1, over what multiplies to positive 8 and adds to negative 6. So that means both my signs are negative, and it ends up being x minus 2, x minus 4. I've already flipped my fraction, so I can start with my factoring. It's a difference of squares, so this is x plus 2, x minus 2, all over, multiplies to negative 6 and adds to 1. That's starting to get kind of familiar, right? X plus 3, x minus 2. X plus 3, x minus 2. Now I can say what my restrictions are, what my x can't equal. X cannot equal positive 2, positive 4, negative 3, and positive 2, which I already have. Now, if I want to put those in number line order, have at it, I'm not going to. Okay. Now it's time to reduce. X minus 4, go searching. I have another x minus 4. X plus 1, I don't have anything for him to go with. X plus 2, nope, I have an x minus 2. I have two x minus 2s. Oh, and look what I have here. So those can reduce. So I'm left with x plus 1 times x plus 2 over x minus 2 times x plus 3. Okay? And that means that I would have vertical asymptotes at 2 and negative 3, and I would end up with a whole. One more, and then we're done. All right. Another division problem coming at you. So that means I need to flip my second fraction. Let's go. The nice thing about these is usually they pick pretty obvious factors, like they're not trying to trip you up when we're doing these problems. So I need to do my factoring. My top one's a trinomial. Let's do x factor. That would be what multiplies to negative 21 and adds to negative 4. Negative 7, positive 3, all over 5 is a GCF, and that leaves me with x plus 3 times difference of squares, x plus 10, x minus 10. And then my denominator, this isn't one I've seen a lot, multiplies to negative 70 and adds to 3. Let's start with the obvious. 10 and 7, yes, that works. X plus 10 and x minus 7. And what's nice is sometimes I use this to kind of repeat a little bit. I look at the other factors I have, and hopefully I have some stuff that's going to reduce to 1. Which I do. X minus 7, x minus 7, x plus 3, x plus 3, x plus 10, x plus 10. Cool. So in the numerator, all I'm left with is x minus 10. And in my denominator, I have 5. Well, that's fun. Now, let's not forget to go back to that last step and write what x can't equal. X cannot equal negative 3, negative 10, positive 7. Okay? So I'm going to have an x-intercept at positive 10. I am not, I'm going to have poles at positive 7 and, or negative 7 and positive 3. And I'm not going to have any vertical asymptotes because I don't have anything left in my denominator. And that's it. So make sure that you answer the questions on the link below the video, and I will see you on Monday. Thank you.